How is load line analysis used with diodes and transistors? Imagine trying to find the perfect spot where a device like a diode or a transistor operates best in a circuit. Load line analysis helps you do just that. It's a simple visual tool that shows how the device interacts with the rest of the circuit. When you work with diodes, you start by looking at their current voltage curve. The load line is drawn based on the supply voltage and the resistor connected in series. It shows all the possible combinations of current and voltage that obey Kirchhoff's voltage law. The point where this line crosses the diode's curve is the actual operating point. This point tells you how much current flows and what voltage drops across the diode. It's a quick way to see if the diode is conducting or blocking current without complicated math. For transistors, especially bipolar junction transistors, load line analysis is a bit more detailed but follows the same idea. You look at the transistor's output characteristics, which show collector current versus collector emitter voltage for different base currents. You draw the load line on this graph using the supply voltage and the load resistor connected to the collector. The load line shows all the possible current and voltage combinations that the circuit can have. There are two main types of load lines for transistors. The first is the direct current or steady-state load line, which shows the transistor's behavior when no input signal is present. It intercepts the axes at points where the collector current is maximum when the collector-emitter voltage is zero, and vice versa. The second is the alternating current load line, which shows how the operating point moves when an AC signal is applied. The intersection of the load line with the transistor's characteristic curves gives the quiescent or operating point. This point is key for designing amplifiers because it ensures the transistor works in the active region, where it can amplify signals linearly. Load line analysis helps engineers visualize how the device responds to different circuit conditions. It makes it easier to predict how the diode or transistor will behave when the circuit is powered or when signals are applied. It also helps in designing biasing circuits that keep the device stable, even if temperature or component values change. In real-world electronics, especially in analog circuits and embedded systems, load line analysis is a fundamental tool. It guides the design of amplifiers, switching circuits, and signal processing stages involving diodes and transistors. It's a straightforward way to see how nonlinear devices fit into linear circuits, making complex behavior much easier to understand.